Hello friends, myself Dr. Sunil Narsingh Bidarkar, Assistant Professor and Head, Department of Mathematics, Sri Muktanand College, Gangapur, District, Aurangabad. Here we see the lecture for BSc second year, Mechanics First, Statics. Already we seen in first chapter, forces acting on a particle, we see the definitions, particle, rigid body, force, equilibrium, an axiom for equilibrium of two forces, statics, resultant of the forces, principle of the transmissibility of force, and law of parallel forces theorem. In this lecture, we see the theorem to determine the magnitude and direction of the resultant vector r of two forces vector p and vector q acting at an angle theta. Previously, we see the vector p, vector q, and vector r, what they have or are. Here we see the theorem to determine the magnitude and direction of the resultant of vector r of two forces, vector p and vector q, acting at an angle theta. Here is the proof. Let the adjacent sides OA and OB of the parallelogram OACB represent the forces vector p and vector q acting at an angle theta. You see here the vector r is a resultant of vector p and vector q, means OC is the resultant, and what is the angle theta? Theta is CAM. Now vector r is equal to vector p plus vector q. We see in the previous lecture. Here we multiplying equation 1, which is vector r is equal to vector p plus vector q by vector r. Then we get vector r composition of vector r is equal to vector p plus q composite to vector r is equal to, means composition of vector p plus q composite to vector p plus q, means vector r is equal to vector p plus q. We see here this in equation 1. Now which implies vector r composite to vector r is equal to p composite to p, p composite to q, again q composite to p, and q composite to q, which again implies in modulo sign vector r square is equal to vector p square plus 2 vector pq plus vector q square, because vector p composite vector q is equal to q vector composite to vector p, which again implies vector r square is equal to vector p square plus 2 vector p vector q and into cos theta, in 12th standard also, plus vector q square, means here we include, when we see the magnitudes of vector p and vector q, here 2 is as it is, and here into cos theta, means includes the angle, which implies r is equal to, here is the square, here under root of r square is equal to under root p square plus q square plus 2pq cos theta, already, which gives the magnitude of r. Through C, draw CM. Here, through C, draw CM perpendicular to OA. Perpendicular to OA. Therefore, angle BOA is equal to angle CAM. Angle BOA is equal to angle CAM is equal to theta. Suppose the resultant force vector r makes an angle alpha with the direction of vector P, then from right angle triangle CMO, from right angle triangle CMO, we have tan alpha is equal to Cm upon OM, Cm upon OM is equal to Q sin theta upon P plus Q cos theta, which implies alpha is equal to tan inverse of Q sin theta upon P plus Q cos theta, which gives the direction of R. Here we see the magnitude and direction of resultant vector R. Thank you.